Hey everybody. So we're getting into 19.4 today, looking at finding the surface area of one last solid, and that is a sphere. All right, so go ahead, take a minute, get this title, get the formula for the surface area of a sphere, and we'll get going. All right, so surface area of a sphere equals 4 pi r cubed, or squared, 4 pi r squared. All right, so actually a really simple formula. Like a lot of these problems that deal with spheres, all we need is the radius of that sphere, and we can type this thing in. So yeah, I guess something to kind of notice. Pi r squared is the formula for the area of a circle. And the surface area of a sphere is 4 times that. All right, so just kind of something interesting to think about. That'll help us on some of our work on upcoming worksheets ever so often. Okay, so yeah, let's go ahead and just try one of these out. Go ahead and copy this and we'll get going. All right, so this is about as straightforward as it gets. First thing to notice, they are giving us the radius of the sphere. So let's go ahead and write our formula. Surface area equals 4 pi r squared. And yeah, we have the radius. So let's go ahead and write it out. So 4 pi radius is 8 squared. And all we need to do is type this into a calculator. So yeah, let's do it. 4 pi 8 squared. All right, so 4 pi, I think we can just press 8 squared. I don't think parentheses are necessary in this. And there it is. We're getting 804.24. We're going to round to the tenths on this. So it looks like that 2 is going to stay at 2. So 804.2. Right. And units are inches, and area, whether it's surface area or just, area, is always units squared. Okay, so yeah, very quick, very simple when they give you the radius. I'm gonna have you guys try one of these problems here. This one is giving you the diameter of the sphere. Okay, so go ahead and try this out, plug in the information, and see if you can find the surface area. Okay, so first thing, surface area equals 4 pi r squared. Excuse me. And on this one, I'm hoping you guys are getting good at this and noticing, oh no, that's not the radius, that is the diameter. I need to plug in the radius, which is going to be half that. So hopefully you plugged in a 5 for radius and not a 10. Okay, so 4 pi 5 10. Let's see what we got. 5 squared. We're getting 314.15. So that 5 is going to round that 1 up to a 2. So 314.2. All right, and looks like we're at yards, so yards squared. Okay, so yeah, those are your typical problems. Though we're gonna dip into a little bit more. So let's take a look. This next slide, you don't need to write this. I just want you to take a look at it. What this thing is describing is what is called great circles. All right, so let's just kind of read through it and we'll break it down. It says, if a plane intersects a sphere, the intersection is either a single point or a circle. So just by the way, a plane, this thing right here, if it cuts through a sphere, usually it's going to be a circle. If it cuts through right at the tip or the edge of the sphere, it would be a single point. So that's all they mean by that. It says if the plane contains the center of the sphere, then the intersection is a great circle of the sphere. So basically, if a plane cuts through a sphere and it goes through the center right there, that circle that's created is called a great circle. All right, you can think of it as like basically the biggest circle that could be made with the sphere. Okay, here's what it says. It says the circumference of a great circle is the circumference of the sphere. Okay, so if you're ever asked, circumference of a sphere, all you need to do is find the circumference of the great circle, which, if you guys remember, circumference, just by the way, is, 2 pi r. Just a little reminder. Okay, it says every great circle of a sphere separates the sphere into two congruent halves called hemispheres. When we were doing our lesson on finding the volume of spheres, we got into hemispheres. And you guys remember, basically, yeah, half a sphere. And that's what it's saying here, though it's getting into the technicality of a great circle being the thing that cuts it into the two halves. Okay, but yeah, just remember when they're talking about a hemisphere, just half of the sphere. Okay, so with that, Let's try a problem here that is asking us to find the surface area, but instead of giving us the radius, this is giving us the area of the great circle. Okay, go ahead and copy this. Okay, so this problem starts to make a lot more sense if we write out the formula. So surface area of a sphere equals 4 pi r squared. Okay, on this problem, it's giving us the area of the great circle, all right? So there would be one way of doing this. One way of doing this would be to plug this information into the area of a circle equation and solve for radius, and then plug radius into our formula. We could do that, though we could also realize that 81 pi is the area of this thing, and that's exactly what this is right here, 4 pi r squared. So what I'm going to do is instead, I'm going to rewrite this. Okay, and instead of pi r squared, I'm going to plug in what the area is, which they tell us is 81 pi. Okay, and then from here, it'd just be a matter of multiplying these together. One thing I want to point out, sometimes you'll have problems that want you to write your answer in terms of pi. When they say that, all they would want on this would be for us to do 4 times 81. That would give us 324 pi. Okay, and if they ever ask you, write your answer in terms of pi, this is what they mean. They mean don't multiply pi times, the number. Just leave it as part of the answer. It's actually a more accurate answer because we're not rounding or anything. So, potentially this could be our answer, but if we wanted to go one more step and actually do what we normally do and multiply that thing times pi, we would get that our surface area is 1017.87, which I'd round that 8 up to a 9 then. Okay, and it looks like that'd be in inches squared. Okay, so just kind of a weird problem, but what I want to kind of point out is, that pi r squared, area of a circle, they gave us the area of a circle right there. So that's why we substituted it. This is not your typical problem. This is just something I wanted you guys to kind of see. Just kind of start getting the wheels in your brain turning. Okay, let's take a look at another problem before I have you guys try one. All right, let's try a problem where it's asking us to find the surface area of the composite figure. All right, so it wants to find the surface area of this whole thing. And, composite figure, you guys remember, it's figures that are made up of multiple solids. Here's what I noticed. Obviously, we have this prism on the bottom. Up on the top here, we have a hemisphere. Okay, so I'm looking to find the surface area of this whole thing. So let's start by finding the surface area of the prism. Okay, so surface area of a prism. So if you guys remember, 2 times the area of the base plus the perimeter of the base times the height of the prism. All right, so let's go ahead and do this real quick. So 2 times area of the base. Well, the base of this prism, pretty obviously, I'd probably consider this thing right here, and it is a rectangle, right? So to find the area of a rectangle, we would do base times height. Instead of plugging in, just b times h, let's plug in the actual numbers and just kind of get to it. So the base and the height of this rectangle will be a 10 times 7. Okay, plus the perimeter of the base here. That's adding together all of its sides. Just remember that means this is 7, this is 10. So 10 plus 7 plus 10 plus 7 would be our perimeter. And just because let's actually do that math. 10 plus 7 plus 10 plus 7. I'm just typing into a calculator. I'm getting 34. Okay, so skipping some steps here just because we're good at this now. Okay, times the height of the prism going from one base to another. That'd be a height. That would too. Okay, and it looks like it's 4. Okay, so yeah, there it is. Surface area equals 2 times, and I'm just going to do this in my own personal calculator. So 10 times 7 is 70. So 2 times 70, 140, and then plus 34 times 4, I'm getting a 276. Okay, so centimeters squared. There is part of our answer. Okay, next thing we need to do is find the surface area of this hemisphere, this half sphere. All right, so here's the idea. Surface area of a sphere is 4 pi r squared. All right, but that would be the surface area of the entire sphere if it was here. We're just doing half. So once we get this answer, we'll take it and we'll divide it by 2. Okay, they're giving us the radius. It's 3, right? So surface area equals 4 pi 3 squared. And then again, after I get that, I'll divide my answer by 2. Okay, so again, I'm going to type this into my own calculator. 4 pi 3 squared is 113.09. I'm going to divide that by 2. And I'm going to get my surface area is 56.54. We'll round that to 56.5. Right. Here's the interesting thing about this. You guys notice the surface area of this hemisphere would not include, I guess if we were talking about this entire box, say we were trying to cover this thing in wrapping paper, we would ignore the base of this, or I guess the circle inside of the sphere, the great circle, I guess I should use that terminology. Okay, we would ignore this thing right here. This actually isn't part of the surface area. It's not on the surface of our shape. It wouldn't have to be covered in wrapping paper. All right, so if we added these two numbers, we would have a general idea of the surface area, but we're actually ignoring the fact that, yeah, that is not part of it. Okay, so what I really need to do is I need to take these values. After I add them together, I need to subtract the area of this circle here. So, pi 3 squared, if I do pi 3 squared, I'm getting 228.3. Okay, so I'm going to add these together and then I'm going to subtract the area of that circle to actually get the real surface area of this thing. Okay, so kind of interesting idea when it comes to that. Okay, so let's see. 276 plus 56.5. Okay, it gives me 332.5, but we realized, then we need to subtract 28.3 and actually get that the surface area of this thing is 304.2 centimeters squared. Okay, and again, that's the tough problem. You wouldn't necessarily get this on a test, but I just wanted you guys to kind of understand, yeah, that the circle there, that's actually, even though it's part of the surface area of the hemisphere, it's actually not part of the surface area of our entire shape right here. If we were to cover this in wrapping paper, we wouldn't have to worry about that. Okay. Cool. So I'm gonna have you guys try one of these on your own. All right. So looks like we have a cylinder and another hemisphere here. So go ahead and find the surface area of this and see. I would maybe start by finding the surface area of a cylinder. If you guys remember, a surface area of a cylinder is 2 times the area of the base plus the circumference times the height of the cylinder. Okay, because these have circular bases. All right, that's where you'd want to start here. So I'll leave that to you and then see if you can make your way. Okay, so the surface area of a cylinder, area of the base, since it's a circular base, I know it's pi r squared. The radius is 5, so pi 5 squared, plus the circumference, which is 2 pi r, 2 pi 5, times the height, going from one base to the other, 14. Okay, so yeah, maybe I'll do this one in the calculator so we're all on the same page. Okay, so 2 times pi 5 squared plus circumference 2 pi 5, and then times the height of the entire thing, which I already forgot, is 14. Okay, so I'm getting 596.90, so 596.9. Okay, in centimeters squared. Okay, now we can find the surface area of my hemisphere, the half sphere here. So again, to find the surface area of an entire sphere, it'd be 4 pi r squared, but it's only half of it, so we'll then take that and divide it by 2 to get a hemisphere. Okay, the radius of this one is the same as this, right? It's 5. So I got surface area equals 4 pi 5 squared, and then we'll divide by 2. Okay, so 4 pi 5 squared gives me this. Okay, and then from there, I'll divide the whole thing by 2. So 157.07 rounds this to 157.1. All right. And just by the way, if you then went and round or added these two values together, the surface area here and the surface area here, you would be close, but you would actually have too much. Okay. And the reason why is because this right here, this circle inside of my shape is not part of the surface area of this composite figure. Okay, so what I would want to do is I'd want to get rid of the area of the circle here. All right, so after I add these together, I would then subtract the area of this circle, pi r squared, and r is 5. So pi 5 squared would give me 78.53, so 78.5. Okay, so that's actually going to give me the answer. So let's see what we get. By the way, if you want to share yourself in your notes, I'm getting a little sloppy on this. So 596.9 plus 157.1 and then minus 78.5. That's going to get us our surface area of the entire composite figure. Okay, so let's see what we got. 596.9 plus 157.1 minus 78.5. Okay, and I'm getting 675.5. Okay, and centimeters squared. Okay, just something, by the way, if I had noticed that this was not part of my surface area at the very beginning, when I went to find the surface area of this cylinder, instead of doing 2 times the area of the base, which by the way is getting us the values of, the areas of this base and this base, I could have just realized, oh no, I only want one of the areas of the base. I could have just done capital B plus circumference times height if I had realized that at the beginning. But I didn't want to confuse you guys by doing that. Okay, cool. But yeah, ultimately, if you guys understood how to find the surface area of a sphere, that's really what this lesson was all about. I kind of wanted to push you beyond and kind of recall some of the stuff we learned earlier. But yeah, that's the lesson, guys. I'll see you.